In this video, I want to have a look at electricity and appliances. So if we want to reduce the amount of money we're paying in bills every month, and we also want to improve our efficiency because it helps the environment, it's really important to understand how and where energy is used in the home. So this graph is from this website, it's down the bottom here. This website has lots of good things about how energy is used in the home and things you can do to reduce your electricity usage. But if we look specifically at this graph, it's all based on averages. So obviously from house to house, it's going to be different. But you can see that the major use of electricity and gas is heating and cooling. So that's 38%. Then we've got water heating, 25%. We've got lighting, 7%. We've got cooking, fridges, freezers, and other appliances, which kind of can all be looked at as the same thing. So we've got 16, 7, and 4%. So altogether that would be 27%. And then we've also got this standby power, which is 3%. So that's standby power. That's things like if you have your TV, you turn it off, but it's still on at the wall, it's on standby. And it's not using much power, but it is using a little bit. So if you have lots of appliances and electronics that are on standby, it can add up to quite a bit of money over the year and quite a bit of electricity. Now, lighting is really important to think about as well. There's lots of different types of light bulbs, and some are much more efficient than others. What we're going to be looking at mostly in this video is these three though, looking at appliances. Now, if we know how much power or how much electricity an appliance is using, or anything is using, it might be a light bulb, it might be anything, then we can calculate how much it's going to cost for us to run that. And we're going to do that by knowing how much power it's used, multiplied by how much the electricity is costing us per kilowatt hour. So our first example asks us, what is the cost of running a 60-watt light bulb for a year, given that it's on for an average of 7 hours per day, and electricity costs 24.627 cents per kilowatt hour. Now there's a fair few calculations to do in this, and you can do each of them separately, step by step, or you can do it all in one, as long as you make sure you don't get lost. So let's start off with, we've got an average of 7 hours a day, and we want over a whole year. So 7 hours a day, we're going to go times 365, and that'll tell us how many hours that light bulb is on for the whole year. Now each one of those light bulbs is each one of those hours uses 60 watts. So we're going to multiply that by 60. To see how many watts of electricity we use over the whole year. But our electricity is charged in cents per kilowatt hour, not watt hour. So that means we need to now convert this from watts to kilowatts. So to do that, we divide by 1,000. Now once we've got all that figured out, that tells us how many kilowatts we're using. And then we're going to multiply it by our 24.627 cents. But first, let's change it into dollars. So we'd have 0.24627. And if we pop all of that in the calculator, we're going to end up with $37.75. So $37.75 to run one light bulb for 7 hours a day for a whole year. Our second example tells us that a 210-watt television runs for an average of 4 hours per day. It asks us to calculate the annual running cost of the TV, given that electricity costs 26.112 cents per kilowatt hour. So we've got very similar steps. We know it's running for 4 hours a day, and we're looking for the annual running cost. So 4 hours a day times 365 tells us how many hours it's on over the whole year. Then we're going to times that by 210, because it's a 210-watt television. But again, because it's measured in charged per kilowatt hour, we need to turn that into kilowatts. So we'll divide by 1,000. And then once we've got that, we're going to multiply by that 0.26112. And figuring all of that out is going to give us $80.06 to run that TV for 4 hours a day for a whole year. The last thing that I want to have a look at is these energy rating labels. So all new appliances will have a sticker on them that looks something like this. And there's two really important pieces of information on there. So the first one is this number down here. So that's our energy consumption figure. And it gives you an estimate of how much energy in kilowatt hours that appliance is going to use over a whole year. So it's all based on average usages, and you can check out what the averages are and what the assumptions are on the energy rating website. But effectively, the smaller the number, the better, because it's going to use less energy. The second thing is this star rating. So some labels will only have these bottom 6 stars, and if something's really efficient, it'll have an extra 4 up the top as well. So essentially, the more stars, the more efficient it is, like it says here. So you want as many stars as you can get. So that helps if you're at the shops trying to decide between 2 different appliances that are pretty similar, you can have a look at their energy consumption. It's also good to keep it in mind because one appliance might be cheaper outright to purchase it, but if its energy consumption is higher, then it's going to cost you more over the long run. So that's just a look at a few concepts to do with electricity and appliances.